Hi, my name is Tindall, and this is my presentation activity. It's on the radar gun. A radar speed gun is a device used to measure the speed of moving objects. It's primarily seen and used by law enforcement, but is also in sports such as baseball to measure ball speed. It is a handheld Doppler radar unit that uses the Doppler effect to detect changes in the frequency of the returning radar signal. Using this knowledge of the Doppler effect, a radar gun detects the changes in the returning frequency and calculates the proportion based on whether the object is approaching or receding. In other words, if an object is moving away from the gun, the returning frequency is measured in proportion to a lower frequency. If an object is approaching the gun, the returning frequency is measured in proportion to an increasing frequency. The gun uses the formula V equals delta F divided by F times C over 2, where F is the frequency and C is the speed of light. The radar gun has many limitations, some of which include stationary, that is maybe for handheld guns or tripod guns. The ones that police use have to be stationary in order to work because of their small size. The small size is the reason it's a limitation because of their small size is an antenna's diameter is less, and anytime an antenna's diameter is less than around 3 feet, directionality limitation occurs and can only partly be compensated for by increasing the frequency of the wave. This results in handheld and mobile radar to produce measurements from multiple objects within the field of view of the user, and is caused because the antenna on those devices is only around 2 inches in diameter. Another limitation of the handheld devices is the use of continuous wave radar to make them light. It is only reliable when the distance where a measure has been recorded is known. This requires pulsed operation when more than one moving object is in the field of view. This also results in detection of a vehicle being detected from miles away while actually targeting a vehicle that may be only 200 yards away. This is troublesome when the field of view for the radar gun is around 130 degrees. Regardless, if someone uses a handheld radar gun, they must always be aware of their surroundings, trees, airplanes, and other objects not noticed by the user, because they might be received by the radar gun if the user is not wary. This is inside the radar gun, and these guns are primarily made such that an antenna is small enough to fit inside the handheld part of the gun, where you can see this tube is. That's where the antennas are. Let's see here. This is where the mixer circuit comes in, where the antenna transmits the signals, and it goes over to this circuit, which is right here, and this has an LED output, so this basically does your calculations right here. It sends this, and this circuit does the calculations of whether or not, or how the frequency is changing over time. And let's see here. Now we have two types of radar guns. The first is a stationary radar gun. The stationary radar detects the returned waves and mixes return signal with a small portion of transmitted signal to calculate a different signal. Then takes the signal and sends it to a digital counter in a circuit inside the gun and calculates the object's speed. That's what we already saw there. This would include obviously a tripod or even a handheld stationary radar, the ones that police use like just a gun. Obviously they must be stationary. This is probably the biggest limitation of them besides the limitations I said earlier. And the other type of radar is the moving radar. And the moving radar uses reflected signals from a target object and stationary objects around the target. It then compares the target signal with the stationary object's signal. The stationary objects could be the scenery around the objects, such as, like you can see here, trees or the road. And these objects, these two cars, are moving. And this produces a different signal than ones around the object. So that's how it uses it. It uses the return signals from the cars, basically, to measure how fast they're going based on the objects around them. This is more advanced and is usually mounted on airplanes, police vehicles, and aboard naval vessels. The difference between these vehicles is the size of the antenna available, thus showing more accuracy. And that's my presentation. Thank you for watching.